Hello everyone. In this video, I will discuss about item analysis. Management of assessment program has to undergo different stages of the system approach. From program planning, the assessment proceeds to organizing, staffing, implementing, evaluating, and reporting. Item analysis is one of the many tasks that every assessor or teacher has to perform before reaching the point of implementing and evaluating. So this lesson presents the discussion of this in details. Item analysis imports three different but important functions in assessment of learning, that is to determine the difficulty index, the discrimination or separation index, and the plausibility index. So we have here the preliminary steps involved in item analysis. First is to arrange the scores of the students from lowest to highest. Next is to get the top 27% of the upper group and bottom 27% for the lower group, leaving the middle 46% as average group. Next is to record the frequencies of those who got the correct answers in each item and for each upper and lower groups of students. Then lastly, do the item analysis for difficulty index, separation index, and plausibility index. First, let us talk about the difficulty index. The difficulty index is a gauge that determines how easy or how difficult the item for the group of learners. So it provides information on the number of students who got the correct and wrong answers in each item. So we will use the formula D is equal to lowercase n divided by the uppercase n times 100, where D stands for difficulty index, lowercase n is the number of learners who got the incorrect answers, and the uppercase n is the total number of learners who were assessed. We have here a table which shows the scale for difficulty index. So we have the difficulty index, evaluation, and the action. If the computed difficulty index is from 0 to 20%, that is very easy. Therefore, we will discard the item. If it is 21% to 40%, that is easy. Then, revise the item. If it is 41% to 60%, that is moderate, then retain the item. If it is 61% to 80%, that is difficult, then revise the item. If it is 81% to 100%, that is very difficult, then discard the item. For example, of the 40 students comprising the upper and lower groups, only 8 got the correct answer in an item. Find the difficulty index. For the solution, so n is equal to 32. Since only 8 got the correct answer out of 40 students, therefore there are 32 students who did not get the correct answer. Then, uppercase n is equal to 40. That is now, d is equal to 32 divided by 40 times 100, which is equal to 0.8 times 100, that is 80%. So this indicates that the item is difficult for the 80% of the entire class, while easy for the 20%. So the desirability of an item must have the difficulty index that falls between the range of 41% to 60%, as it was shown from the table a while back. In this given example, it is proper for the framer of this item to revise. That is difficulty index. Next is separation index. The separation index is otherwise known as discrimination index. This index determines how valid the entire test is for a group of learners. So it provides information on the number of learners who got the item with the correct answers in the upper subgroup and those in the lower subgroup, and the ratio of the difference between the two subgroups and the total numbers of learners in the entire group. The index provides the discriminating power of an item for the group. We will use the formula S is equal to the quantity Nu minus Nl divided by N times 100, where S stands for the separation index, Nu stands for the number of learners in the upper subgroup who got the correct answer, Nl is the number of learners in the lower subgroup who got the correct answer, and N is the total number of learners who were assessed. So we have here a table which shows the scale for separation index. So if the computed separation index is from 0 to 10%, that is very low, then discard the item. If it is 11% to 20%, that is low, then revise the item. If it is 21% to 30%, that is moderate, then retain the item. Then, if it is 31% to 40%, that is high, revise the item. If it is 41% to 50%, that is very high, then discard the item. For example, of the 40 students, only 8 got the correct answers. So 6 from the upper subgroup and 2 from the lower subgroup. Find the separation index. So Nu, that is 6, Nl, that is 2, and N is 40. So computing now the separation index, that is 6 minus 2 divided by 40 times 100. That is equal to 0.1 times 100, which is equal to 10%. So the obtained index provides that the item has the power to discriminate the students at 10%. In contrast, this item brings the entire learner to have 90% homogeneity in getting the wrong answer. So the desirability of an item must have the separation index that falls within the range of 21% to 30%. In the given example, or in this example, the item must be discarded. That is separation index. Lastly is the plausibility index. The plausibility or breaking index is applicable to an assessment using a test instrument with 4 or 5 options for each item. Noting that the minimum option for a multiple choice assessment instrument is 4. This index determines the extent which the option distracts the focus of the learner on the correct answer and persuades to other options. Hence, if the learner is uncertain or doubtful of the answer, this option has the persuasive factor as the alternative, though wrong. In the determination of plausibility index, each of the option must have been chosen as an option for the item in relation to the total upper and lower groups used in the item analysis. Hence, we will use the formula P is equal to lowercase n divided by the uppercase n, where P is the plausibility index, the lowercase n is the total frequency, and the uppercase n is the total number of students in both groups. So we have here a table which shows the scale for plausibility index under 4-option test and 5-option test. So under 4-option test, if the computed plausibility index is from 0.25 and up, that is excellent. Therefore, you will retain that choice. If it is from 0.20 to 0.24, that is good, then retain. If it is 0.15 to 0.19, that is fair, then revise. If it is 0.10 to 0.14, that is poor, then discard that option. If it is 0.09 and below, that is very poor, then discard. Same is true with the 5-option test. If it is 0.20 and up, that is excellent, then retain the choice. If it is 0.16 to 0.19, that is good, then also retain the choice. If it is 0.12 to 0.15, that is fair, then revise. If it is 0.08 to 0.11, that is poor, then discard. And lastly, if it is 0.04 and below, that is very poor, then discard. For example, in a total of 40 students in both upper and lower groups and in a 5-option test item, there were 6 students from the upper group and 2 from the lower group who got the correct answer. Determine the plausibility index of this item if the 4 options got the response frequencies in both groups as follows. So this is a 5-option test. So we have from the upper group and the lower group. Under option A, 5 from upper group answered and 4 from the lower group answered with option A. With option B, 8 from upper group, 9 from lower group. For option C, wala ang sumagot sa upper, then 2 from lower. For option D, which is the correct answer, 6 from upper group and 2 from lower group. And option E, 1 from upper group and 3 from lower group. So we have here the total number of students who answered in each item, both from, or each option, both from the lower subgroup and the upper subgroup. For option A, 9, a total of 9 students answered. For option B, there are 17 students. For option C, there are 2. For option D, there are 8. And for option E, there are 4. So we have a total of 40. Then computing now the plausibility index, that is lowercase n over the uppercase n. So for option A, that is 9 divided by 40, which is equal to 0.23. For option B, that is 17 divided by 40, which will give us 0.43. For option C, that is 2 divided by 40, which is equal to 0.05. Then for the correct answer, which is option D, that is 8 divided by 40, which is equal to 0.20. And for option E, 4 divided by 40, which is equal to 0.10. Then for evaluation and decision, for option A, that is excellent. Therefore, we will retain that option. For option B, that is also excellent, then retain the option. For option C, that is poor. Therefore, discard that option. For option D, that is excellent, then retain. For option E, that is poor, then discard. So that is about item analysis. Thank you for watching and I hope you have learned something.